Here is my presentation on humidity, which is basically water in the air, water vapor. Earth is the only planet in our solar system that really has a lot of water in the air. Part of what makes Earth so special is that we have ice, which is solid water. We have a massive amount of liquid water, which make up the oceans, and we have water vapor, which are the clouds. We're the only planet I'm aware of with all three phases of water existing in large quantities, part of what makes Earth so special. Um, One other interesting thing about the water vapor in the air is that it really varies from place to place. Some places, like deserts, only have 0.01% water in the air, whereas if you go to a rainforest, the air might be 4% water. Uh, Other gases are not like this. So, for instance, oxygen. It's not like you're going to go to the desert and suffocate. All right. So, it's a good thing that Earth's oxygen is constant from place to place, but the water vapor really varies. One other thing to note is that water vapor is almost all in the troposphere, which is the bottom level of the atmosphere. When air is holding all of the water vapor that it can, it is said to be saturated. So that's what fog is. That's when air is full of water. It is holding all the water that it can. It's kind of like a sponge. When a sponge is full of water, you would say it was saturated. Air can also be saturated, as you can see. It's also what a cloud is. That's saturated air. Absolute humidity is the amount of water in the air. This is an actual quantity of water. For instance, if you said there's a gallon of water in the classroom's air, that is the absolute humidity. It is the absolute amount of water in the air, like if you put it in a cup. Warm air can hold more water than cold air. So, for instance, if I have air that is at 20 degrees Celsius, which is about 70 degrees Fahrenheit, that air can hold almost 2% water. But if you take the same air and you cool it down to freezing air can only hold less than 1% water. This is a big difference. This has major implications for Earth's weather, because what if you take saturated air that is at 70 degrees and then you try to cool it down to freezing? Well, water is going to have to come out of the air, which is why we have rain and dew and things like that on this planet. So this is a big deal, causes the water cycle. Now, remember, absolute humidity is the amount of water in the air, but we also have to talk about relative humidity. Relative humidity is how much water is in the air divided by, that's what this line means right here. This is a math equation. So it's the absolute humidity divided by the max absolute humidity at that temperature is the key part. Because remember, the amount of water air can hold changes with temperature. So relative humidity takes temperature into account. Absolute humidity does not look at the temperature. So these are two different values that we need to take into account to understand humidity. So for example, when we go from 10 degrees to 20 degrees to 30 degrees, you can see in this example that the amount of water in the air is not changing. That's what's represented by this blue circle. So that would be the absolute humidity. It's staying the same throughout the day. But notice that if this is the morning, by maybe 11 a.m., the air has gotten hotter. Now it can hold more water. That's what this yellow part is representing. So the relative humidity has dropped from 100% down to 52%. Although the amount of water in the air is still the same, all that's changed is the temperature. So when the temperature changes, the relative humidity also changes, even though the amount of water has not changed. It's just that the air can now hold more. Now, by 1 p.m., you might heat up to 30 Celsius, which is about 80 degrees Fahrenheit. Now the relative humidity is only 28%. Once again, the absolute humidity stayed the same, but the temperature changed, and that changes the relative humidity. So therefore, the hotter it is outside, the lower the relative humidity is going to be. You can think of that as how wet or dry it's going to be. So this right here is really, really dry, whereas this is going to be pretty wet and damp out. So why does relative humidity matter to you? Well, when relative humidity is 100%, water is not going to evaporate. So if you go outside and you try to run a race at 100% relative humidity, all of your sweat is going to stay on your skin and you are going to get wet. Sweating is only effective if the relative humidity is low, because water only evaporates if relative humidity is low. So basically, the lower the relative humidity is, the faster things will dry off, including you. At 100% relative humidity, the temperature is at the dew point. It's the definition of dew point. It is the temperature where relative humidity would be 100%, which means the air is full of water or saturated. No evaporation occurs at the dew point. So if I go outside and ride my bike when the temperature is at the dew point, I'm going to get wet because all of the sweat that I put out is going to stay on my clothing. It's going to be gross. On the other hand, if the relative humidity is like 30%, that's going to be very, very dry. In those kinds of conditions, it might be good for exercise because your sweat would evaporate quickly, which cools you off. But fires are going to start very easily in low relative humidity conditions. So that would be fire danger weather. Water would also evaporate rapidly. So let's say you left a cup of water outside, it might dry up in the course of a day or two in really dry conditions. Dew point is the temperature at which relative humidity is 100%. At the dew point, fog appears and dew forms. So, let's see. I'm not really sure exactly what this example is supposed to be showing. It looks like in this example, the dew point is 55 degrees. Since at 55 degrees, the relative humidity is at 100%. But notice, if you take that same air and heat it up to 80 degrees, that drops the relative humidity down to 42%. So this air right here, which is at 80 degrees with 42% relative humidity, would be said to have a dew point of 55. Since if you cooled that air down to 55, the relative humidity would rise to 100 and it would be saturated. The temperature can never go under the dew point. So it is basically like the basement temperature. If the dew point outside is 30 degrees, that means the lowest it can get is 30 degrees outside. So I like to know the dew point so I know how cold it can get. Once the dew point is reached, fog will appear and everything will get wet. Dew point is basically a measure of absolute humidity. And it's not a direct measurement of absolute humidity because it doesn't actually tell you how much water is in the air. But dew point is directly correlated with absolute humidity. So just by knowing the dew point temperature, you basically have an idea of how much water is in the air. So for instance, the lower the dew point temperature is, the less water is in the air. So 37 is a pretty low dew point. That means there's not that much water in the air. 55, a dew point of 55 is actually pretty comfortable. That means there's a medium amount of water in the air. Fog would form at 55 degrees, whereas a high dew point would be like 74. That's like a really, really humid day in Atlanta during the summer. That means there's a massive amount of water in the air. At night, the temperature wouldn't be able to get below 74 because of all the water in the air. And that would just be very, very humid, oppressively humid. So when I want to know the absolute humidity, I look at the dew point. And after years of looking at dew points, you start to get used to it and you get an idea of how certain dew points feel. Let's see. So relative humidity goes up and down every day with temperature changes. If you look right here, this green line is the relative humidity.